Hey folks, it's Duke here from GeoFolks. Today we're talking about latitude and longitude. So latitude is defined as an angular distance in degrees, minutes, and seconds of a point north or south of the equator. Lines of latitude are often referred to as parallels. Longitude, on the other hand, is an angular distance in degrees, minutes, and seconds of a point east or west of the prime meridian, which is in Greenwich, England. Lines of longitude are often referred to as meridians. So you can see here, what we're doing is, if we had a hypothetical center of the Earth point, we're going to measure the angle between that point, the equator, and a point that we want to find the latitude for, which is the red dot here. So we can see here, this point is around 30 degrees from the equator, and that is our latitude measurement. Longitude, on the other hand, is the same measurement where we have that hypothetical center of the Earth point, but we're going to measure it from the prime meridian to that point, to the point of longitude that we're trying to figure out. So we're going to determine what angle with the center of the Earth our point makes, and that's going to give longitude. The rule of thumb, if you're looking for longitude, if the value you're looking for is west of the prime meridian, it's considered west or negative. And for latitude, if the value is south of the equator, it's considered south or negative. So to give you a little bit more context and show it how these two fit together, we can see here, we're trying to find the latitude and longitude of point P. And so what we can do is we can use that center point again, point C, as we have circled here. We can derive the latitude by taking that angle between the equatorial reference plane here. And also for point P, we can also take that angle between the prime meridian and whatever meridian P intersects. Latitude and longitude work together to give you an exact point. So this is just another example. If you were to grid out the parallels of latitude and meridians of longitude, this is how it would look. You try to get a grid system in which you can pick points. Like let's say we want to identify this point here. We can see, okay, what's 40 degrees north latitude and then -30 west longitude. So just ways you can start to tease things out using the grid that latitude and longitude create. What happens when we're not perfectly on a degree mark? Well, that's when minutes and seconds come in. So minutes and seconds allow you to effectively break up the degrees in order to make your measurement more accurate. So within a degree, 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. So if we look at the course drawing on our right, if we were to take 1 degree and split it 60 different times, each one of those 60 different splits would be a minute. So by refining our measurement and making the unit of measurement smaller, we're making our accuracy greater. We're essentially zooming in so we can figure out the angle that we're at and then find a minute within that angle that we're at as well. Because not everything is going to be perfectly at 30 degrees. Some things are going to be at 32 degrees in 15 minutes. So going from minutes to seconds is a similar thing. 1 minute is equal to 60 seconds. So if we were to divide a minute up again into 60 times, each one of those parts would be a second. So just another way to zoom in for even more accuracy, to give yourself more resolution. So to give you more of an example of degrees, minutes, and seconds, let's look at this. Let's focus on latitude only, so anything with an N in front of it. So the difference between N41 and N42 is about a degree. So if we were to break that degree up into 60 equal intervals, then we would have 60 different minutes. As we zoom in, we'll see how minutes can add more resolution. So the boxes north 41 30 minutes represents halfway between that degree mark at the 30th minute. And you can see that for N41 and N42. As we zoom further and further in, you can see as we go from degrees to minutes and seconds, we get more resolution, zeroing in on one specific spot. Here we're demonstrating how minutes themselves are broken up into seconds. We can see the entirety of the 16th minute here is roughly broken up vertically between these two red boxes. So if you follow the arrow between the two red boxes, we start off in the 54th second of the 15th minute. So right before that 16th minute is going to start within the 41st degree. And then we go all the way up to the 6th second of the 17th minute. So right after that 16th minute is done. So I hope this brief example helps you understand latitude, longitude, and degrees in minutes and seconds, and how degrees in minutes and seconds give more resolution as you zoom in on the globe. Thanks for watching, and comment if you like these GIS fundamentals. If you found this video helpful, please like, subscribe, and hit the notification bell for more content.